Increasing or decreasing functions. State the intervals on which the given function is increasing, decreasing, or constant. Many of you have a question, increasing, decreasing. Increasing is going up, decreasing is going down. But from where? Always from left to right. So let's go ahead and see this graph here. So when I start from the left hand side, the graph is decreasing, 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 decreasing up to this point. And what exactly is this point? This point is -1. So from negative infinity, so remember this one, when I say this one, when I say this value, remember there's an arrow, so this graph could be extending, and the respective x value could be somewhere on the negative infinity side. So negative infinity to -1, the graph is decreasing. All right, from -1 the graph goes up. That means the graph is increasing. So from -1 to infinity, because the graph keeps going all the way up, the graph is increasing. All right, so please make sure you always go from left to right. And again, the complete definition of increasing or decreasing functions. A function is said to be increasing in an open interval if f of x1 is less than f of x2, where x1 is less than x2. And the function is said to be decreasing if f of x1 is greater than f of x2, where x1 is less than x2. And it's a constant when f of x1 is equal to f of x2 in the interval x1 and x2. Okay, so what does this mean, f of x1 less than f of x2? Let's look at this one here. This x1 value is 1, x2 value is 2. x1 is less than x2 because 1 is less than 2, and the function value here is 0, and 0 is less than, for 2 the value of 2 is somewhere here, 0 is less than 1.5. so see, as you go from left to right, if the function is going up, it's increasing. As you go from left to right, if the function is going down, it's decreasing. Relative maximum, relative minimum. A function value, say f of a, is relative maximum if there exists an open interval containing a such that f of a is greater than f of x for all x not equal to a. The same condition applies for relative minimum. The function value f of b is said to be relative minimum in an open interval such that f of b is less than f of x for all x not equal to b. What exactly does that mean? So when I look at the function here, let's start from a particular interval. I'm starting from this side. The function is going down, 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 down until 3. So for this part here, the relative minimum is going to be, for this part here, relative minimum is going to be -3. So the function has relative minimum of 0. This is the minimum value, right? So function has the minimum of 0 at -3. So minimum, relative minimum, actually it should be relative minimum of 0 at -3. Now I'm going to keep moving, and the function is increasing, 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 increasing until this point. So the function has a relative maximum. What is the maximum value? 4 at 0. And again, from 4 the function falls down at y is equal to 4 and x is equal to 0. The function falls down, decreasing, decreasing, decreasing. Again, it's a minimum. So the function has relative minimum. Minimum of what? What's the minimum value? Minimum value is 0, not the y. You're not looking at the x value, you're looking at the y value. Function minimum value is 0. And at what point? At +3. Remember, always minimum and maximum values are the y values, not the x values. Even and odd functions. A function is even if, I'm just going to write it here, if f of x, f of negative x is equal to f of x for all the x in the domain. The function is said to be odd if f of negative x is equal to negative of f of x when x is replaced by negative x. Alright? In other words, a function is said to be even if its symmetry along y-axis. So it's same on both sides of the y-axis. And the function is said to be odd if the function is same on both sides of the origin. That is, if it's not both sides of the, it's symmetry along origin. In other words, I should say the function is said to be odd if it's symmetry along origin. I don't have place here, but I'm going to squeeze this in here. Okay? If it's even, it's symmetry along y-axis. If it's odd, it's symmetry along origin. And how do I check for this one? There's so many ways of checking. You can graph this function. So let me go ahead and graph this function and then show it to you. When I graph the function, this is what I get. Okay? When I graph the function, that's what I'm going to get. So I see that this part of the function is simply the mirror image of this part. So when I flip this function along the origin, when I close this along the origin, this is what I get. So it's an odd function. That's one way of seeing. The other way, what I'm going to do is I'm going to take the function f of x and I'm going to replace x with negative x. When I replace, what do I get? Negative x cubed minus x. And wait a minute, this is same as negative of f of x. Right? This is same as negative of f of x. How is that? When I take out the negative sign common, what do I get? X cubed plus x. And what is x cubed plus x? The function f of x. So from here I get that f of negative x is negative of f of x. And what kind of function is that? When I root it back to the equation, it would be an odd function. So this is an even, this is an odd. So this becomes an odd function. So many ways of working it out. You can graph it and check if it's symmetry along origin, or you can simply change your x to negative x and then work it out. Problem 3b, when I graph it, and I look at the function, I want you to graph and look at the function here. The function neither looks like it's even nor odd. So the function doesn't look like it's neither an even function nor an odd function. So when I graph it here, I'm just going to show a small graph of this one. It is something like this. So it's not symmetry along y-axis because it's always towards, it's more towards the left-hand side. I can't draw it exactly, but I want you guys to go ahead and graph it in your calculators and see it's not symmetry along y-axis. Or what do? I simply replace my x with negative x and check. So this is x squared plus x, negative of x squared minus x. So what do I get? I get x squared minus x. So when I get x squared minus x, it's not negative of g of x. Alright, so this one here, it's not equal to negative of g of x, it's not equal to g of x. So in this case, g of negative x is not equal to negative of g of x, nor it's equal to g of x. So it's neither even nor odd. So it's neither. Alright, problem 3c. If you go ahead and graph it, then you would have a function, let me go ahead and graph it here, minus x to the power 4 Yeah, when I graph this function, I would have a function something like this. And this function is even, or its symmetry along y-axis, so this would be a even function. Or again, you can go ahead and replace your x with negative x. Alright, piecewise functions. Alright, this is a piecewise function. The name itself tells you that we're going to draw the function piecewise. So we have two pieces here. One when x is less than or equal to 0. The other one when x is greater than 0. The easiest way to look at the function is look at this way. Y is equal to 2x. If x is less than or equal to 0. And y is equal to 2 if x is greater than or equal to 0. So I'm going to go ahead and draw my graph here. So 0 is my point here. 0. So I have two functions. Less than or equal to 0, which is going to be on this side. Greater than 0, which is going to be on this side. First, I'm going to work with greater than 0. Y is equal to 2 for greater than 0. So every time I take greater than 0, I'm going to take a couple of values here. 1, 2, 3, 4. All these are greater than 0. So when x is 1, this is 1, 2, 3, 4. When x is 1, what is y? 2. When x is 2, y is 2. When x is 3, y is 2. When x is 4, y is 2. When x is 5, y is 2. That's what this says, correct? When x greater than 0, y is 2. What happens when x is 0? I can't take it. So this value, this 2, should be a open parenthesis, open circle, sorry. And then it's going to be a straight line. Alright? Now less than 0. When it's less than 0, it's 2x. So that means when x is negative 1, negative 2, negative 3, negative 4. When x is negative 1, 2 times negative 1 is negative 2. So negative 3, negative 4. So 1 and negative 2, 2 and negative 4. So this is going to be the graph of the line y is equal to 2x. And in this case, the question is it open circle or closed circle? Look at this one. It's greater than or equal to 0. So when x is 0, this is a closed circle. For this one, it's just greater than, not greater than or equal to. So it's going to be a open circle. Alright, simply find and simplify the difference quotient. So the difference quotient formula is f of x plus h minus f of x over h. So first let me go ahead and find f of x plus h. What do? Instead of x, you replace it with x plus h. So instead of x squared, I have x plus h squared. Instead of 4 times x, I have 4 times x plus h plus 3. Right? Minus f of x. What is f of x? X squared minus 4x plus 3. Remember, you should always have your parentheses so you don't mess up your signs over h. When I simplify the numerator, what do I get? X squared plus 2xh plus h squared minus 4x minus 4h plus 3. The negative gets distributed. Minus x squared plus 4x minus 3 over h. Positive x squared, negative x squared cancel. Positive x, negative x cancel. Positive 3, negative 3 cancel. What am I left with? 2x h plus h squared minus 4h divided by h. So I see that I can factor a h out from here. When I factor it out, what do I end up with? 2x minus 4 plus h over h. H and h cancel. I end up with 2x minus 4 plus